Good evening, everyone. Today we will discuss some mathematical problems of chopper circuit. So, already we have completed the lessons regarding chopper classifications, quadrant operations of chopper, and the equations. Now, to do the mathematical problems, firstly we have to summarize the things. Suppose here we consider a basic DC to DC converter circuit. So that is a basic DC to DC converter circuit. Here it is a circuit that is works like a step down chopper. So this is the circuits of a step down chopper, and that is the corresponding waveforms. Now already we have discussed about the principles and the circuits and the waveforms of these choppers, and from there the formulas that we have derived, that is firstly alpha, we know that the duty cycle that is equal to T on by T, that means the percentage of time conducting mode. V0, that is the output voltage of this chopper across the load, that will be equal to alpha Vs. Alpha means T on by T, and another formula that is we can derive from here, that is T on by T, that means 1 by T means we know that frequency f into T on into Vs. So these formulas we have derived already from the basic chopper circuits. Now suppose from this lesson you have to consider about some parameters. Number 1, average output voltage and current. Number 2, output current at the instant of commutations. Number 3, RMS value of the output voltage of chopper. Number 4, RMS and average value of thyristor current. And number 5, effective input resistance of a chopper. Now suppose here we know that the load can be resistive or inductive, or maybe that is a capacitive load, but here we considered as a resistive load. So when we are considering a resistive load, we know that for resistive load the voltage waveform and current waveform that will be similar, because for resistive load both are in the same phase. Now for the average output voltage calculations, so the average output voltage we know that already V0 equal to alpha Vs, that is the average output voltage. So this average output voltage is actually implemented here. Now the average current, what will be the value of average current? We know the average current value going to be voltage divided by the resistance, as it is a resistive load. So the I0 will be V0 divided by R. So what is V0? V0 is alpha Vs divided by R. So that will be the average output current with respect to the source voltage Vs. Now number 2, what is the questions? Output current at the instant of commutations. So at the instant of commutations, the thyristor commutated the current, that means the time is then T equal to T on. We know that from this waveform, that is the waveform here, that is the total time period T, this is T on and this is T off. So at the instant of commutation, that means T equal to T on. So when T equal to T on, what will be the value of current? We know that at the T equal to T on time, the current will be the maximum current, that is Vs by R. So the voltage by resistance. So I0 at the time of commutation, at the instant of commutation, the output current will be I0 equal to Vs by R. So this is another parameters we derived with respect to the source voltage Vs. Now the RMS value of the output voltage, here the source voltage is Vs and the output voltage is V0, but when we are going to considering about the RMS value, so what is RMS value? From the basic mathematical derivations, we know that the RMS value formula is Vrms equal to root over of 1 by T integration with respect to the time V square t dt. That means here this V square is the value of the voltage. Here the V square means Vs square, because for the output voltage considerations, the input voltage is actually Vs, that is going to supply the load. So that means here the voltage is considered as Vs. So V square means, as per the formula, that is V square. So V square means it will be Vs square, and 1 by T, that means here the time period consideration. So when we are going to consider the time period, here we actually have to consider the duty cycle alpha, actual the conducting time. So that is T1 by T. So as per the formula, that is root over of 1 by T integration with respect to time V square T dt. So integration with respect to time V square dt, the value will be, that is Vs square. And when we are considering about the time period, so time period here, the conducting time period, that is alpha. So that is T1 by T. That means the RMS value of the output voltage will be root over of T1 by T V square. So that means V square, the root over of V square, that means Vs, root over of Vs square, that means Vs, and root over of T1 by T. T1 by T means we know that is as a duty cycle. So root over of T1 by T means root over of alpha. So the output voltage, RMS value of the output voltage with respect to the input voltage will be root over alpha Vs. Now if we considering about the average thyristor current. So average thyristor current means the current that is coming from the source, that is actually going through the chopper circuit. So average thyristor current will be the current value of average output current. So what is the average output current? The average output current equal to alpha Vs by R. So this output current is actually the current coming through the chopper. So the average thyristor current, that value is also will be alpha Vs by R. And again, if we considering about the RMS value of the thyristor current, then what will be the RMS value? The RMS value, as per the last formula we already derived, the RMS value will be again the conducting time period T1 by T, and the value of current is Vs by R square. That means root over of T1 by T into Vs by R square, that means root over alpha into Vs by R. That will be the RMS value of the average thyristor current, and that is coming from the concepts of RMS value here, that is root over 1 by T, 0 to T, T0 to T plus T, V square T dt. This is the basic formula of RMS value. Now from that formula we can derive this, that is root over alpha Vs by R. Now if we going to considering about the average source current. So what is the average source current? So average source current, that means that will be the average thyristor current, that is the average source current is going to flow through the thyristor. So that is the average thyristor current, that is already we derived previously alpha Vs by R. So input resistance of the chopper, what will be that? The input resistance will be obviously voltage by current. Resistance means we know voltage by current. So the source voltage is Vs and the source current is alpha Vs by R. So it is the Vs cancelled out. So what will be the value? That will be R by alpha. So these are the formulas, that is the summarizations of some formulas, and we actually here it is derived with respect to all the parameters we derived with respect to the source voltage Vs. Now we will go for a problem. So what is the problem? Here that is a type A chopper where the source voltage, input voltage is 230 volt. Load resistance is considered here 10 ohm, voltage drop 2 volt across the chopper when it is in on conditions, alpha, that means duty cycle is 0.4. Now the conditions calculations is calculate the average and RMS value of output voltage and chopper efficiency. Now when we are considering about the average and RMS value of output voltage, so already we get the formula. So what is the formula? In our previous lesson we see that the average output voltage equal to V0 equal to alpha Vs. So if we apply that here, So what happens? That means V0 equal to alpha Vs. Now what will be the value of Vs? Here the value of Vs, that is going to be Vs minus 2, because as per my problem here the voltage drop equal to 2 volt. That means across the chopper voltage drop 2 volt means the actual voltage here comes, that is Vs minus 2. So if this is Vs minus 2, that means the alpha is considered here as a 0.4. So 0.4 Vs. So Vs value is 230. 230 minus 2. If we do the calculations, that will be 91.2 volt. That is the average output voltage. Now RMS value of the output voltage. So as per the formula, what is the formula of RMS value? So RMS value, if we consider the RMS value, so what is the formula? Again, in previous lesson we find the formula of RMS value of the output voltage, that is root over alpha Vs. The RMS value of the output voltage equal to root over alpha Vs. So root over alpha Vs means here that is root over alpha into Vs. So what is the value of Vs? Here Vs will be root of Vs will be Vs minus 2. Again we have to consider it as it is a Vs minus 2 because of that 2 volt voltage drop. So root over of 0.4 230 minus 2, and if we do the calculations, that is 144.2 volt. Now this is the first part of the problem. In the second part we have to find out the chopper efficiency. So what is efficiency? The efficiency means that is with respect to inputs and outputs we have to get the value of efficiency. So output by input. Now to derive the efficiency we have to now consider about the power output or power delivered to the load and also the power inputs of chopper. So what is the power delivered formula? So power delivered P0 equal to obviously V0 square by R. So this P0 is the power delivered to the load. So the load voltage is V0. We know that from our circuits. So that is V0 square by R. So V0 square by R means we already get the RMS value of the output voltage, and we have to consider the RMS value as it is the effective value. So that is 144.2 square divided by the resistance. As per our problem, the resistance is here considered load resistance 10 ohm. So 144.2 square divided by 10, that means the power, if we do the calculations, that will 2079.364 watt. Now if we consider the input power, so input power means obviously the input voltage and the current going through the circuit for that input voltage. So that is I0. So 230, Vs is 230 we know, and I0, what is I0? The current I0 is going to be voltage divided by resistance, because current we know that is voltage by resistance. So output voltage I0 means V0 by R. So V0, what is the value of V0? The V0 value is 91.2 volt. So this is the value of V0. So 91.2 divided by 10, and from this is 2097.6 watt. Now we get the value of output power and input power. So what will be the efficiency? So the efficiency will be P0 by Pi, that is 2079.364 divided by 2097.6 into 100%. That means that is going to be 99.13%. So this is the calculations of efficiency of this chopper. So this type of math is very much important, and here we do the total calculations of the average value, RMS value, and the efficiency we can get from the output power and input power. So these all, and from this type of formula, using this type of formula, you can do the maths. Thank you.